evaluate these composite functions? Well, this is from section 1.4 out of the textbook, and this question, there's two right next to each other, so I decided to do these. So they're telling us for part A, to what is the radius. So they're telling us the radius as a function of the volume, and then we can find the volume as a function of time. So then they're asking us, why don't you find the radius as a function of time? So we took our radius function right here, and we're going to replace v with the v of t function. So I'm sure that's probably okay for you. So I'm just going to write 10 plus 20t. And then what we need to do is, that's actually part A. You could clean it up a little bit, but we don't need to take care of part A. Now for part B, we need to find the time when the radius equals 10. Now remember, this is equal to the radius, because now what we've got a radius as dependent on time. So what we're going to do is we're going to set this function equal to 10 and then solve it. So to do this algebraically, analytically, if you see me say solve it analytically, that means you want to do the algebra. So I'm going to I got to do the inverse operation of taking the cube root. Undo the cube root, I'll say. So I'm going to cube both sides of the equation. So 10 cubed is 1,000. And that clears up that. I'm also going to distribute that 3 through. So 30 plus 60t all over 4 pi. I'm going to multiply both sides by 4 pi because really now what I have is a proportion, right? So I've got 4,000 pi equals 30 plus 60t. I'm going to subtract 30, then divide by 60. And what's that as a decimal? I don't know, I would need a calculator for that. But that is a solution. So I decided to fire up a calculator and actually figure out what the decimal equivalent of that is. And so this is telling me that when t equals about 209 seconds is when the radius is equal to 10. We can also solve this graphically, and what I did is, this is out at desmo.com, and what I did is I graphed I defined the two functions, then I had to graph the composite function, and that's this green graph, and I had to change my scale, and I said, where does this f of t equal 10? So that's why I graphed, here's the y equals 10, here's the f of t function, and notice I'm getting the exact same answer I did analytically. When t or x is, actually we get this in terms of t. When t is 208.9, y is equal to 10, and that's what we found algebraically. So now the problem that's like in my open math is this, and they're asking us to find the composite function. So since we want to know, let's see, the capital N is the number of bacteria based on the temperature. And then the temperature based on time is this function. So they're asking us to find the number of bacteria based on time. So in this second function, I'm gonna replace it with the 5t plus 1.5. And that's pretty messy to clean up. I mean, we certainly could. There's other ways to do that. You know, you'd have to FOIL this out. So 25t squared plus, let's see, 7.5, and 7.5 is 15t plus 1.5 squared is what, 2.25? And you'd have to distribute the negative 56 through. You get the idea. And the combined like terms. Or we'd have to distribute the 23 through also, right? 23 has to get distributed through. Then combine like terms. So the second part of this question is asked us find the time when the number of bacteria equals that number. So I expanded this, condensed it, and I said, okay, so when is this function equal to that number. And so it's a quadratic equation. I know it's a quadratic equation because of the t squared. So I set it equal to 0 because that's what you do when we solve quadratic equations. Okay, and I could try to factor it. I could use the quadratic formula. At this point in your mathematical careers, I'm happy, we're happy if you just, oh, it's a quadratic equation, quadratic formula. I got to solve it. Set it equal to 0 and solve it. So what I did is I have this IOSS. Will this let me expand? Oh, I guess it won't. This is iOS app that has, besides a graphing calculator and a regular calculator, it has a bunch of polynomial solvers. And all it's asking you for is A, B, and C in your quadratic equation, right? This is in the form ax squared plus bx plus c equals 0, just like with the quadratic formula, right? Where you go negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's what this is asking you without doing all the work. Okay, and this is telling me, of course, that there's two answers, and one's a negative, and since we're talking about time, the negative doesn't make sense. It's not really in the domain. So when the time's 3.378 seconds, the population of bacteria is equal to that number. That's doing it analytically. So if I wanted to solve this graphically, as you can see, I didn't do a whole lot of work with this. I left this all, just substituted in my first equation. I put the value I wanted in my second equation, and then I graphed them. And if you look and see, here's that intersection here. Let me get that out of the way. You can see that intersection there. See, there's this line, and then the red function is the quadratic function, this one here. And we're seeing the two intersections. And if you remember that graphing, the problem, this polynomial solver app gave me the negative answer and the positive answer for x. And notice it's showing I was looking for this intersection. I knew I wanted the positive one, and that's the same value. So that's solving this graphically. And as I said before, if I don't say do it analytically, a graphical approach is fine.